Let's see, are we clicking? Well, I'm clicking. Oh, there we go. Okay, so I think we've heard through many sessions today about all of the opportunities within the financial space. Recently, I did some research on some of the information we're getting from some of the consultancies. Deloitte, McKinsey was one of them, and I put this quote up here today to say that tomorrow's financial service winners and losers are going to be basically determined on how you can deploy and scale AI, and specifically generative AI, right? And so what does that mean when we think about all of the opportunities that are out there, right? We have this, this is, all right, sorry. So some of the opportunities out there and some of the things that we've seen that companies or financial organizations are doing, and I think we heard some of them in some of the earlier sessions, these things around fraud detection, this identification of SARs and advanced fintech and enhanced fraud monitoring. We see things in the risk management space around risk reporting and policy monitoring and some of these other applications. And many financial institutions are in the throes of doing this and leveraging generative AI to do that. Other areas are in the areas of customer interaction, where we see chatbots and more advanced chatbots. And this idea of even getting closer to hyper-personalization. And with some of the new things like open banking and stuff coming in, the pressures around how you're going to get to that information and how you can really take advantage of these types of technologies and opportunities are really becoming something that organizations really have to get their arms around. Things like personalization, this idea that customers are having more demands of how they actually want to be, how they want to be seen by their organizations and interact with those organizations. And in many of these areas and for many of these opportunities, there is this need for leveraging real-time information, right? Because obviously we know that when we do that, we get better decisions, we get up-to-date responses, and fundamentally better accuracy in our endeavors. But some of those challenges now around how do we leverage real-time data, particularly in the space of generative AI, right? So I know that there have been some talks earlier around leveraging generative AI in policies and compliance and those types of applications. But what does that mean when we look at some of these real-time opportunities that we can have to satisfy some of these new desires that we have to do? And that kind of takes us back to how do we actually work with LLMs? And so what I'm going to start talking about here is what is this RAG pattern that we hear people talking about? And basically, it starts with how we actually have to interact with LLMs to begin with. I know we heard a lot of conversations about getting the prompt right. So basically, this idea of prompt engineering, where RAG becomes one technique for doing that. And the need for it is because typically, when we send that request or prompt to, these things are moving faster than I am, to an LLM, the LLM really doesn't understand our organizational data. And so the question becomes, how do we now bring our organizational data into that dialogue, if you will, with that LLM, right? And so this idea for retrieval generation means that the first thing I need to do is I need to find something relevant within my organization so that I can now augment that prompt that I send to the LLM so that LLM now has more information that's relevant to my organization. That LLM can then better generate a response that makes sense to the users. So what is the R in RAG, right? And what is that retrieval, right? Now, so most of us are familiar with this idea of what I'm gonna call semantic search, and fundamentally what it is, where we have unstructured data, it's vectorized into a database. But fundamentally, when we do this type of retrieval, we are looking for things that are semantically relevant or semantically related to that prompt. And in some instances, it works very well, right? If I'm looking for documents or compliance. But in some use cases, it may not be sufficient for some of the things that we need to do. Another approach for retrieval is to combine this idea of this vectorization with graph databases where we can now traverse and get information that's not only semantically relevant, but also related to that. And so we can augment the prompt and the information that we're giving to the LLM so that we can get better responses. But what I want to offer today, and I think it was brought up in our earlier conversation, is this idea of leveraging this power that LLMs have to do code generation or to work with these structured formats, SQL being one of those. This idea that you can request something in natural language and have it converted into basically SQL code so that you can actually retrieve information that's structured throughout your organization in any of your systems across your organization. And how that allows you to not only empower your end users, but to empower some of these technologies that we listed earlier, as well as this positioning for these agentic workflows and autonomous agents. And so what may not be known by us, SQL is the fourth most popular language. And this is followed behind JavaScript, Python, and C++. And what that means is that a lot of people know it. It's ubiquitous. The BI tools that we use, like the Tableaus, the Power BIs, and all of these tools are all based on SQL. And so a lot of the things that you can do with those tools, SQL is the engine behind that, right? And so we keep that in mind, that if we think of unleashing SQL through natural language across our enterprises, what can that do for us, right? Not only within the BI and analytics space, but also the acquiring of information for some of those real-time opportunities that we need. One other thing is LLMs are really good at it. They're very, very good at generating SQL. They're good at code generation. SQL's another form of code, and LLMs can really, really generate them well, given the proper information or context for them to do that. And this kind of leads me into what we call the query RAG pattern. And there's two parts to that pattern. The first part is, how do I retrieve information about information within my organization? Okay, and so that would be my first request, is to my organization to give me some information around something. Like there could be a customer, it could be a policy or something like that. So that first part, once I get that information about something, I can now give it to that LLM and say, take this question or request that I have, here's some metadata to support it, give me a SQL query. And this part of it works very well within LLMs. The second part of that follows the general RAG pattern where I now can retrieve information from my organization by leveraging that query that the LLM gave me. So I can execute that query, and now I can send that augmented request to that LLM, and I can get summarization. Some of these LLMs, they can do visualizations. They can do analysis on that information that comes back. And just this functionality, these capabilities of LLMs becomes very, very powerful and can open up a myriad of possibilities. And you can start to get your mind racing about the things you can do with just that idea in mind. But in order to do that, some of the things that we need to consider around that is how bringing our data to generative AI can really get the ROI that we need, right? So there's a lot of questions, and depending upon what those outcomes are and what that implementation is, you can get larger ROIs or lower ROIs. Things like, what is my enterprise data architecture? How do I stabilize my investment? How quickly can I adapt and iterate and deploy, right? So these are things that are typical in most, when you consider most technologies, but generative AI more specifically. And so the story we have today has to do with query RAG and a data fabric. and specifically a logical data fabric. And we'll get into some reasons and some justifications as to why logical is a very, very good implementation of this. Query RAG and data fabric leverages the strengths of LLMs, as I described earlier. It implements the RAG approach, so a lot of this patterning is something that's known, and your AI developers can still work within that. It simplifies development, and we'll see how the data fabric allows that a little later. Provides that consistent interface to your organizational information. It adapts, so you get dynamic metadata and the actual data through this type of architecture, and that you can apply it to data anywhere and still have that consistency and framework associated with it, with secure execution and optimized execution. And so you can start to see how when you have this consistency, you can build frameworks around it, which means that you have support, you have this ability to scale processes and many other things around that in order to ramp up your implementation. And so we're going to go back to our components of our RAG or our conversation with an LLM, where this idea we have something like an application or an agent, and ideally you want some type of stable framework or consistent interface for your information to be able to communicate with your LLM. AI models today, particularly LLMs, many of them are available, and a lot of times there are frameworks that allow simple communication to these LLMs. The only thing left, therefore, is now how do I get simple, consistent interaction or connectivity to my organizational data, given that I have all these challenges, right? I have most of us have a dynamic data ecosystem. Things are typically distributed. It could be in multiple clouds. And a lot of our data ecosystems are just complex and varied, and we've even heard siloed and other challenges that we've all discussed earlier. And so that pretty much extends into this idea of how do I now have this application or agent communicate with all these different entities, right? So where is my semantics now, right? So in order for me to get good interaction with my AI model, I'm going to have some subset or some consistency around the metadata that I'm actually interacting with that LLM with. Where am I going to do security, right? And how do I manage that, particularly when I want to scale my AI application or agent, and maybe I want to reuse it, right? So we're seeing a lot of lift in APIs that are wrapped around these agents as well. And so when you think long-term around how do I actually do that, considering all these capabilities, these are things that we need to be able to work through. And so as far as a logical data fabric, this is how that works within that framework, right? And so, for instance, the logical data fabric, in this particular case, I have two cases here. It's wrapped within a data catalog, right? And that catalog is searchable around data assets that are in your organization, but they're logically represented in that data fabric. And so now what happens is when you have a user, for instance, that has a question about, in this case, a customer that's been represented in your logical data fabric, that conversation now can be mitigated through that data fabric because the data fabric is in possession of the metadata or the information around a customer. So it now knows what to prompt the LLM for in order to get the SQL query to satisfy any questions that user may have around that customer. And then the data fabric can basically do the rest of that work as far as executing that query securely, bringing that information back, and the user can now have access to what those responses are. And this is This is something that's built into data fabrics, like the Denoto platform. It's built into that. And what that means is all of the information that supports that customer. Say, I have customer information that's in Salesforce. I have some that's in, some systems that I have on-prem or maybe in multiple clouds. When we look at real-time scenarios, a lot of times those interactions may happen, at different times. And so the idea is, how can I be real-time and not have to worry about whether I'm replicating or synchronizing many of my systems? And so the idea here is that data fabric can now take that simple representation of that customer that's now generated in a query, right? So if I generate a query on a single customer entity, I'm going to get a much better, simpler query than if I have to generate a query that's going to go across multiple systems, right? And so this idea now is that it doesn't matter where that is. It can execute across the enterprise, and the responses come back. And this means that these types of queries are available to anybody in your organization through objects or entities that you deploy. And so when you look at a logical data fabric such as this, you get it's a ready-built generative AI application. Data can be managed and moved around anywhere in your enterprise, but yet those queries or those representations of those objects will still work because we're leveraging abstraction, which is a software engineering principle, right? And so this idea that we can move things around, change things out. In some instances, there's acquisitions or mergers or applications that get obsoleted or moved around. And these become something that are not concerned for the actual applications themselves, right? And so from a stability standpoint, it becomes very advantageous. Also, because it's a logical data fabric, I can now have a simplified view of not only a customer, but other things like accounts or policies or whatever entities that are in the enterprise. And now I can get simpler queries, which are going to increase the likelihood of those queries being generated correctly, because there's fewer information for the LLM to actually have to work with. This idea of this data frag it extends out into applications where you can actually build yourself, right? We can now, instead of having the actual logical data fabric as the application itself, you can still build applications that actually go through the same kind of pathway and follow the same pattern. And one thing I just want to note, that the beauty or the necessity of patterns means that when you put something in place, when you talk about support, when you talk about a building, extension, change control, all these things become now predictable, and these processes can be built on an abstraction layer separate from the actual work that has to do with the data. And so a lot of times that will stabilize your investment in many applications, and this can extend even beyond generative AI applications as well. Right, and so now the same customer can now interact with an application or an agent, and this customer can even be another agent or another system, right, that can now interact with these same components. And there's this idea now that you can even control the flow, right? So what do I mean by that? There are many RAG patterns. I think we heard earlier that there was one application where they had challenges with questions and answers, right? And so there are different techniques around how you do prompt engineering. And so this also allows you to intercede there, right? You can get information about that customer that's in the logical data fabric. You can execute that query, and you can also determine what that prompt looks like in between. So you have a lot of flexibility around how you actually interact with the actual LLM, right? So you can pull the data you need, get whatever metadata you need, and still choreograph or orchestrate those interactions between that, which makes that a very powerful platform. So now when we start looking about some of the applications we saw as far as personalization and risk management and reporting and things like that, we see that now we have a consistent pattern-based approach to actually how we can facilitate these. And it still works through the same idea, this consistent interface, through the same idea where wherever things are in the organization that fulfill these entities, we can still execute on them. So it becomes almost boring, right? Because now we're actually going through the same type of patterning. And for instance, so the Denodo logic fabric actually has an SDK that actually helps do that. So now you have these components that are ready-made, just like you have like a LangChain or something like that. You have an SDK where you can actually work with the information within your organization, frameworks around your UI. So however you want to do that, you now have not only this ability for frameworks and consistency of how you actually interact, but now there's this idea of separating out who can do what right now. So typically in a lot of organizations, in a lot of cases, we put a lot of this onus on our developers to actually do a lot of this data wrangling and securing and things like that. And so now with these different components, you can see that you can start to decouple how that actually works and now have teams of people that now can do what they do best. We'll talk about that a little later. This also extends to highly distributed landscapes. So in other words, those landscapes don't have to be in the same area. They don't have to be in the same country. They don't have to be in the same region. So you can even have this idea of managing your data assets wherever you need to by whatever your organizational policies are, but still have that consistency of how that generative AI application is going to function, leveraging that logical data fabric. Right, and so I can expand and move out, and my applications are still going to remain stable, so my investment is stable. My support structure is stable. My development is stable, because now I'm using frameworks and patterns in order to do that. And so, as I said before, it now takes a look at where we're seeing a lot of trending as to how you actually work. I think I heard it in another session where there are teams of people that do data, people that do governance or whatever. And so now what this starts to look like within the organization is I can treat data as my asset, and I can manage it and validate it, and I can do it separately. I can secure it. I can have people that understand the rules and regulations around security, securing my assets and my data. I can have my AI developers focusing on building AI stuff, right? So they don't have to get bogged down in this, okay, what is this? I got to go off and talk to 15 million, people to figure out how I'm supposed to restrict access to something when all I want to do is my AI stuff, right? So you have this idea of having people focused around your data and your application initiatives based on what they do best. And once you're able to do that, then that means your organizational structure around that can start to level out and become predictable and therefore more efficient in that manner. I recently ran into an article, I think it was in, I have it here, CIO magazine. I thought it was interesting. It talked about how generative AI is kind of like the Apollo mission, in that generative AI, like the Apollo had a bunch of flaws and failed, and was like, oh my gosh, how did it even work? Right, and that generative AI is kind of like that, in that it's implemented, and we know that there are flaws, but the promise is so much, and this idea that we know that it's going to get better, we still leverage it, and it has that power to transform, as they indicate, a generation. And if we look at some of the advancements around AI and generative AI, we see that LLMs are getting better. I mean, because everybody sees that promise. There's a lot of work and energy that's been poured into them. Interactivity between data, we're starting to see that those are improving. We have improved accessibility. We have faster technology for both storage and compute. And so in the future, we can see that the idea for this is definitely on the trend or trending to get better and to improve. But what's necessary in order to do that is to now settle on how you can structure your organizations and how you work so that you can take advantage of that, right? So, for instance, I was in industry, and my motto was, okay, I'll decide what my architecture is, and I'm going to rely on the promise of things to improve. And we see that in technologies such as, such as generative AI. Some real fast takeaways from that article was that you have to adapt fast, right? And I think we all know that, and we feel that. We rethink the ways of working, and that's kind of what I indicated in that chart here, is when you decouple, what you're doing from your application space and your data space, you can start to level out how your organization has to work. You can get faster learning cycles. And this idea around creating option value. And that's kind of what a logical data fabric brings. This idea that you can manage the rest of your organization and your business as you need to, and still keep your application stable because you're running through this logical architecture, which in turn helps you to scale not only just the technology, but your actual processes themselves, right? Sorry. Okay, it doesn't really want, okay, so these are the key takeaways. Everybody knows generative AI is transformational, but query RAG as the pattern, and that in concert with a logical data fabric, it will help you to realize significant potential, and that a logical data architecture helps you to be stable, to do things quickly, and to more easily get AI ready from those types of use cases around structured data. And you can also scale efficiently with a logical data fabric. And so that's all I have here. Sorry I went over.
Thanks so much, Terry. Excellent presentation. Are there any last questions for Terry?